What makes something exponential? Our basic equation for an exponential graph is this y equals ab to the power of x. That's what an exponential is going to look like. It's some value multiplied by a number to a power. That number to the power, the b to the x, that is what we look for something that's exponential. The fact that our x is in our exponents. That's why it's exponential. Looking at this equation, all of the information we just got from the graph above can be seen by looking at the values of a and b. So if we see that a is greater than 0, if a is greater than 0, then it is going to end up pointing upward. We don't know if it'll be up to the left or up to the right, but we know it's going to be upward. If a is less than 0, it's going to be downward. And because I like to be complete, a is greater than 0, a is less than 0. Well, the other option is a is equal to 0. Hopefully you can see if a is equal to the 0, then this is just y equals 0, and it is a line. We'll even say it is a constant. It's always 0, which is boring. Boring. And thence also not really exponential, because 0 times b to the x, well, it's just 0, so it's not an exponential anymore. A is also always the y-intercept. It's that value when x is 0, because if x is 0, b to the 0 is 1, and so we just have a value of a. Later on, we will add things to this, but this is your basic exponential, and we won't be talking about that addition until much later. So there's what a does for us. It tells us if it's up or down, and then it tells us the y-intercept. A is the y-intercept. What about b? Well, if b is greater than 1, it is going to be up/down on right. And it also means that the approach the asymptotes on left. So it will go up or down on the right, and it's going to approach the asymptote on the left. If 0 is between b and 1, or if b is between 0 and 1, then it's going to be exactly the opposite. It's going to be up, down on left, and it's going to approach the asymptote on the right. If b is less than 0, well, if b is less than 0, we're going to have a negative to the power of x. And a negative to a power really only makes sense on integers and some fractions. But if it's to a power of a half or something like that, it doesn't work. So when we're talking about an exponential, b is never allowed to be negative. So we'll just say cannot. B cannot be less than 0. Again, if b is equal to 0, it's boring. It's always 0. If b is equal to 0, then it's just y equals 0, which is boring. If b is equal to 1, well, then it's just always a, which is not quite as boring, but again, boring. So all we really care about is b is positive, not equal to 1. So here are our options. Again, let's look at some examples using this to help us see what's happening. If a is greater than 0, it's going upward. If a is less than 0, we're going downward. If b is greater than 1, it's up or down on the right, and it approaches the asymptote on the left. If b is between 0 and 1, it's up or down on the left, and it's approaching the asymptote on the right. And the others we don't really care about. The one thing I didn't mention is the asymptote. The asymptote is always y equals 0. Again, I say it's always y equals 0 for these functions when we're just using y equals ab to the x. If we add some more meat to the exponential function, the asymptote moves around. But for the ones we're doing, we're always dealing with an asymptote of y equal to 0. All right, easy enough. Let's take that information now, and again, hopefully you're copying this down as we go. We're going to take that information and we're going to actually draw some graphs. All right, so what is the graph of y equals 3 to the x? Well, starting off from our equation, we can look at this and we can see that the a is equal to, well, there's nothing out here, so it's 1. And the b is equal to 3. So again, talking about what we looked at before, a is positive, so it's going to point upward. I'm just going to say up. B is greater than 1, so it's going to be up to the right. So the a is equal to 1 tells us up. B is equal to 3 tells us that is to the right, because B is greater than 1, because A is greater than 0. All right, so what about this? Is it increasing or decreasing? Well, the fact that it's going up to the right tells us that it is increasing. We know that it's going to be getting bigger as we go to the right, so it is increasing. Now, we have to be careful. Just because it says up doesn't mean increasing. Just because it says to the right doesn't mean it's increasing. If it's going down to the right, it's decreasing. If it's going up to the left, it's decreasing. So we have to really think through what these are talking about. The y-intercept, well, the y-intercept is always a. So y equals 1. Why is y 1? Because a is 1. The horizontal asymptote, well, I already said with these, it's always y equals 0. And why is it always y equals 0? Well, the idea is if x is a really big number, then this is big. But if x is a really big negative number, in this case, we get 3 to a really big negative number means 1 over a really big number, which is basically 0. So that's why this horizontal asymptote is y equals 0. And it approaches on the left. Well, it has to approach on the left because it goes up to the right. So it's going to approach the asymptote on the other side. So let's draw the graph then. We know the y-intercept is 1. So we will go ahead and put a point at 1. We know it's going to go up to the right and it's going to flatten out to 0 on the left. How do we know what? Well, let's just try one. What does this 3 to the x mean? Well, it means we're multiplying by 3 every time we go over 1. So 1 times 3 gives us 3. 3 times 3 gives us 4, 5, 6, 7, 8, 9. 9 times 3 gives us, way off the graph, 27. If we go backwards, we're dividing by 3. So 1 divided by 3 gives us 1/3. 1/9, 1/27, and we're already basically 0. So our curve is going to be flat, wow, that was good. Basically 0, and then climbing up. That is unacceptable. And if you're drawing your graph, I shouldn't see that. I do want to see the curve going flat along this. If you want to use a ruler for part of it to actually draw that straight line, that's fine. So here's our basic graph for y equals 3 to the power of x. Let's look at another one. Let's see. What if we have this one? Y equals -3 to the 1/2 x. Well, again, let's start out by listing our variables, we know that a, in this case, is -3, and b is 1/2. So, what do we know then? A is -3, so that means that it's going to point down. B is 1/2, so B is between 0 and 1, which means it's going to be on the left. So again, we look at this and we see A is -3, so that tells us it's going to be down. B is 1/2, so that tells us it's on the left, because we have 0 less than B less than 1. Now, what do we know? It's going down on the left, which means it's going to be a rough curve, something like this. Well, down on the left means it is increasing. Again, the y-intercept is simply A. So the y-intercept is -3. Horizontal asymptote is always 0, and it approaches on the opposite side, so it approaches on the right. Okay, sketch our graph. Y-intercept of -3, 1, 2, 3, -3. And as we move to the right, we multiply by half. Well, half of -3 is -3/2. 3/2 times a half is 3/4. And then 3/8. And then 3/16, and we can see it flattening. So we're going here, we're dividing by half, which means multiplying by 2, so this becomes 4, 5, 6. 6 times 2 becomes 7, 8, 9, 10, 11, 12, about there. And so we have our curve. Okay, that one was a little bit better. But we can see, like we guessed, it goes down to the left. It is increasing, has a y-intercept of -3, flattens out at 0, and it approaches 0 on the right. All right, so I leave you with 4 more problems to try to graph.